This is now another tracing of induction with 50 Hz burst, induction of ventricular fibrillation correctly sensed by the device, charge of the capacitor. The first shock, 65 joule, is delivered but is inefficient. Then redetection of the arrhythmia and onset of the second charge. The second shock is now delivered but is also inefficient, so 80 joules inefficient. And then you can see here the artifacts corresponding to the shock delivered by the external defibrillator. In this patient with two inefficient shock, one 65 joule in standard polarity and one 80 joule in reverse polarity, we decided first to evaluate the high voltage impedance, which was normal. When this impedance is too high, it may suggest that the lead has been tunneled too superficially along the sternum and that the coil is not deep enough. So in this patient, since the impedance was within normal range, we checked the positioning of the leads and of the can under fluoroscopy, and we could see then that there was potential for improvements of the shock vector, placing the can in a more cranial position. So that's what we did. We had to reposition the can, and then that's the new induction, and you can see now that the first shock is efficient. So to summarize, with a subcutaneous ICD, most of the time the first shock at 65 joule is efficient. When it is not efficient and the second one is efficient, you may have to consider to reprogram the polarity of the first shock to the reverse polarity. If it is still non-efficient, in some patients you need to accept a reduced safety margin of less than 10 joule. If the two shocks are inefficient, then you need to reconsider the positioning of the lead and or the can. If despite optimization of the shocking vector, the shocks are still inefficient, then you have to reconsider the implantation of a subcutaneous ICD.